so we're going to be talking about vectors in the coordinate plane. And take a look at these vectors here, right? So suppose I have a vector v, okay? And it looks like that, right? What we're going to do today is we're going to figure out the components. We're going to use the coordinate points of the terminal and initial points in order to figure out the lengths of the components. So suppose this initial point is at 5, 6, and this terminal point is at, 9, 9, okay? And now suppose I draw the x component and I draw the y component, right? Using the coordinates, is there any way to figure out what is the length of the red component, the x component? Yeah? So I would just do 9 minus 5, right? And that would be a length of 4. So what did I do for that one? I did x2 minus x1. And for the y component, I would do the same thing, but now with the y's, right? I would do 9 minus 6 equal to 3. And what would that get me? That was y2 minus y1. And so I find that the y component is 3, okay? So what does that mean? Now that I have this x component of 4 and this y component of 3, what does that mean? That means that if I started at my initial point of A, in order to go to the terminal point of B, what do I have to do? I have to go 4 units horizontally and then 3 units up vertically, correct? So that's what that told me. Now, there is another concise way to write that, okay? And the more concise way to write that is, I can say, okay, to go from point A to point B, you go 4 in the horizontal direction and 3 in the vertical direction. But in order to say that this is a vector that we're talking about, we put it in what we call vector brackets, which are these triangular brackets.
Oh, wait. That's what Alex always messed up.
And now I say, guess what? This vector AB is equal to that. And so now, all I need in order to be able to reproduce vector AB is that the stuff in those brackets, 4, 3. I start at a point, go 4 horizontal, go 3 vertical, and I got my vector AB. We call this the component form of a vector, all right? So how do we get the component form? It's basically x2 minus x1, comma y2 minus y1 in the brackets, and that is it, okay? All right. I'll take questions in a second. Let me do an example here. So take a look here. It says to find the component form of vector AB with initial point A, vertical point B. Okay? All right. So take a look. This is x1, y1. This is x2, y2. Does the order matter? Yes. 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 So the component form of AB, right? I say AB is equal to, bracket, x2 minus x1, y2 minus y1. So AB is 0, 6. Okay, let's just wrap our heads around this. That's just straight up, says Evan. Well, let's see. What were the initial and final points here, the initial and terminal points? A is 1, negative 3. B is 1, positive 3. So that is vector AB, right? And is that consistent with the component form? The component form says start at A, go 0 units horizontally, go 6 units vertically, and oh my God, yes. Okay? Aren't mathematicians just so clever? Right? Yes. So now comes the point of a magnitude, right? How do we do the magnitude? Well, let's get back. Let's get back to like algebra, right? If back to this diagram here, if I know that this has a length of 4 and this has a length of 3, you did a little bit of this on your homework. How did you find that magnitude? What would you do to find the magnitude of the vector AB? Do you have to do inverse tangent? That would give you the angle. How would you find that hypotenuse of this triangle? Pythagorean theorem, right? So to find the magnitude of AB, I just do the square root of 4 squared plus 3 squared, right? Yep. But where did we get 4 from? What was 4? Remember, we just did x2 minus x1 to get the 4, right? So that's squared. And then that one was y2 minus y1, so that's squared. So basically, to find the magnitude of a vector, you just do the square root of, x2 minus x1 squared. That's basically the distance formula, right? But also, you can just do the square root of the first component squared plus the second component squared. So, take a look here. We want to find the magnitude of AB, same vector, right? So here's what you do. Write in component form. And in component form, vector AB was 0, 6. In component form, this is always A, this is always B, right? I mean, we just label them A, comma B. To find the magnitude of AB, all you have to do is take a square root of the first one squared plus the second one squared. So AB magnitude is just 6. All right, questions about vector addition and subtraction. Do you guys remember how to add and subtract matrices? Mm-hmm. What did we do to add and subtract matrices?
1, 1, and 1, and 1.
You just basically added identical components, right?
Yeah.
Okay. Component. To add vectors, you do the same thing. So for example, if I had a matrix 1, 2, 1, 1 plus 2, 0, 0, 2, what did I do? I just added the corresponding components and put it here, right? Yeah. Well, guess what? Vector addition is the same thing.
It's like 1 by 2 matrices.
Oh my God. Actually, a vector is a row matrix. That's what a vector is.
Together.
There is a nirvana out there.
It's like right there.
There is a math nirvana out there where you find that everything is related in more ways than you can possibly imagine. So that's all a vector is. It's a row matrix. So to add two vectors, you just add, corresponding components. And then to multiply by a scalar, same thing. It's like a row matrix. That's all it is. So take a look here. We got W, Y, Z. We want to find 2W plus Y minus 4Z. So this is 2 times W plus 1Y, 2 comma 0, plus minus 4Z, -1, -4. Okay? So this is, when you distribute the 2, 4, -10, 2 comma 0. And now here with the negative, you kind of have to be careful, right? Do you want to distribute the negative or not? You know what? I'm going to be a rebel, not distribute the negative. I'm just going to distribute the 4. So this is going to be -4, -16. Or if you distribute the negative, it'll be plus outside, right? So now, adding them up, you add up all of the A's. So it's 4 plus 2, 6, minus 4, 10, comma, -10, plus 0, plus 16. That's just a what? -6. Plus 6. Okay, -10 plus 16. Yeah? So it's +6. Everybody okay? And that's it. We just added those two vectors.
Wow.
Should we do another one?
Yeah.
Are you guys cool? Yes. Okay, so 3 times y, 2, 0, minus 2 times z. Okay. Distribute the 3, 6, 0. Okay, this time I'm going to distribute the -2 because it's less counterintuitive. So I get plus 2 and 8. So this is 8, 8. Okay. Now, as an extra, if you wanted to find the magnitude of 3y minus 2z, okay, and you have the component form, all you do is square root the first one squared plus the second one squared.
Oh, nice.
Yeah. Okay? All right. Let's talk about a unit vector. Okay, the big part about a vector is its direction, right? That's like a major part of a vector.
Huge.
Yep.
It's not a vector without it. Most important.
It's the most important. It really is. So a vector just gives everything its direction, okay? Now, sometimes all you care about is the vector's direction, not necessarily the size of it. In that case, it doesn't really make much sense for you to carry around these long, huge vectors everywhere, right? If all you need is the direction. So to do that, we could basically just scale down the vector so that it's 1 unit long, right? And so it's literally just like the hand of a clock. It just points somewhere. We call that a unit vector. It's a vector with magnitude of 1. Okay? So if you have a vector v, the unit vector is usually called u, because why not? What else, right? It has the same direction of v, but a magnitude of 1. So take a look here at this vector v. This is vector v. It's got a length of 2.5 units long. This little itty bitty one is the vector u. It's only 1 unit long. So how do I take v? Okay, what do I do to v? Okay, if I take v, what should I divide it by in order for its size to be 1? Itself, right? So if it has a length of 2.5, I just divide it by its length and I get the vector v. Okay? So here, okay, you take the vector v, and if you divide it by its magnitude, you get the vector u, the unit vector. So we say the unit vector u is equal to vector v in all its glory divided by the magnitude of vector v. Okay? So that is here. So to find the unit vector, just divide v by its magnitude. Okay? Questions? Okay, so take a look here for a minute. Find a unit U with the same direction as V. Okay, so first, find the magnitude of vector V. Okay, the magnitude of V is the square root of 4 squared plus 2 squared. Since it's squared, I can get rid of the negative.
Did we put the V in that one?
Yes. So magnitude of V is 16 plus 4 root 20, which is 2 root 5. Do you have to simplify your radicals? Yes, you do. When do you have to simplify your radicals? All the time. Okay. Next, vector U is just vector V divided by the magnitude. So, vector U is, what is vector V? Vector V, you say? It's 4 comma negative 2 divided by 2 root 5. Nope. Because when you multiply or divide by a scalar, you just distribute it to each of the components, right? So this one, it'll be 4 over 2 root 5, negative 2 over 2 root 5. So this will be, simplify, 2 over root 5, negative 1 over root 5. And that is your final answer. Do you have to simplify fractions? Yes. When do you have to simplify fractions? All the time.
I thought we didn't have to here.
Oh, you have to simplify them. You don't have to rationalize them. So like... Yep. Okay, so, let's just find out what we've done. Okay? What is it that we've done? So let's see. Because this all seems a little abstract, right? Okay. So here's what I'm going to do here. I'm going to draw, one second. Okay, I'm going to put in a vector, coordinate plane here. Let's just see what it is that we're doing. Okay. All right, so first, you know what I'm going to draw on here? Is, with this one, I'm going to draw vector V. So vector V, you start with the origin, and you go 4 across, 1, 2, 3, 4, and 2 down, right? All right, I'm off a little bit. Here. Does that look like vector V to you? Right? 4 across and 2 down. Yep. Okay. Now, guess what else I'm going to draw? I want to draw now vector U, right? So here, remember how we found vector U? I want to draw vector U, but I don't know how much 2 over root 5 is. Can somebody tell me how much is 2 over root 5? Anybody have your calculator on you? How much is 2 over root 5?
I'm doing it, don't worry. We've got 0.894427.
Yep, 0.89. And you know what? This one is negative. It's half of it, right? So it's negative 0.48-ish. Okay?
Do we have to find that?
No. You don't have to do this, but here's why I'm doing this. All right, guys, so take a look. So now I'm going to draw vector vector U, and we said it's 0.89 minus 0.48, right? So here we go. Start here. I'm going to go 0.89 to the right, and about halfway down, look at that. Look at where it lies. Do you see how it lies exactly on top of the old vector?
No way.
But it's just got a magnitude of 1. You see that? So it's kind of hard to believe, but that's exactly what we just did. Okay? Isn't that cool? Right? Okay.
It seems hard to believe.
So let's move on here.
Not bad.
So now that we have some unit vectors, right? I can have a unit vector pointing in any direction. But you guys are beginning to get the idea now that when vectors are pointing straight, like totally vertically and horizontally, those are like the preferred vectors, right? So take a look here. Look at this. This is a unit vector because it's got a length of 1 and it's plainly on the y-axis, okay? Look at this one. It's got a length of 1 and it's completely on the x-axis. These are the VIPs of unit vectors. In fact, they're so VIP, they have their own name. This vector here that lies directly on top of the x-axis and it's a unit vector has the name italicized I with a little hat on top. And we call it I hat.
Created.
Its components are 1, 0. This one is the J vector. It's J hat, and its components are 0, 1. So I hat and J hat. In French, it's called like that accent mark, it's called the chapeau. So it's literally like, which means hat. So that's where the hat comes from because that accent mark is a chapeau. So I hat, J hat, and these are like actual things. So that means, just like little Legos, I can use I hat and J hat vectors in different combinations to create any vector. Take a look here. I used 3 I hats. 3 I hats. And how many J hats to create this one?
4.
1, 2, 3, 4 J hats to create that one. So that vector V, what is it in component form? It's 3, 4, right? But it's also, I can write it another way. It's 3 I hat plus 4 J hat. Okay? So there are 2 ways to represent V. And this is called component form. And this one is a mouthful. It's a linear combination of I and J. Okay?
What's the point of writing it with that I hat and J hat if it would take maybe longer?
In different applications, the different components are used. So for example, like in physics, okay, take physics. In quantum mechanics, a lot of time we use, because everything is matrix based, we use the component form. But let's say like in talking about like electricity and magnetism, and you have to describe like, you know, the electric field and so on, it's more customary to talk about the I hats and J hats.
Is the I hat and J hat just like the more you know kind of thing, or is it going to be applicable?
Is it going to be what?
Is it going to be applicable for like our homework and tests?
For your homework, you have to know each of them equally well.
All right.
But don't worry, because, you know, listen, this is going to be such a little problem, right? You remember at the beginning of the pandemic, Zoom, it was like everybody was trying to figure out how Zoom works, and now it's like, oh yeah, let me just set up a meeting for you, right? It's kind of like that. It seems like a new thing now, but you'll get used to it. Okay, so let's do this one thing as well, and then this one problem as well, and then we can stop. let DE be a vector with initial point this and terminal point that. Write DE as a linear combination of the vectors I and j. I like to first put it in component form. It's easier for me. So DE, right, is 2 minus minus 3, 6 minus minus 3. DE is 5, 9. Okay. Do you have to write this step every single time? No, right? I get it. I mean, you guys could, I know that you can go from, just straight to 5, 9, which is cool with me. In linear combination of I and j, DE will equal 5i plus 9j. Okay? So, for example, if you had a vector, 3, negative 2, what would it be? And yeah.
3i plus minus 2j.
Exactly. Okay, and if it was, let's say, what if it's like negative 2, 0? Then it's just negative 2i.
Oh, wow.
I know, because it's plus 0j, which is just 0. I know, okay? All right, so I will stop here today. And your homework is on the lesson plan. It says part 1.